Hey, beautiful people. This is Coach Yoakum, and I am going to help you with the grade 8 AMI day 29. And so before we start today, I'd just like to encourage you to stay in contact with your teachers over the next few days because as the AMI work for next week and the last 3 weeks of school is pushed out, you're going to need some clarification on some of those expectations, and so make sure you're in contact with your teachers. Okay. With that said, let's take a look at today's work. All right. So as I look, I notice I have a data table. And the title of the data table says the magnetic North Pole movement. And then I notice I have a year of reading, which means the year that it was measured. The second column there says distance moved since previous reading, and the unit is kilometers there. And then the third column says average speed, and the unit is kilometers per year. Kilometers per year, not a typical speed measure, but in this case, that's the unit of measure. Okay, so let's take a look at the questions. Number one, what is the trend in the speed of the pole's movement? Okay, so this question really focuses on the speed of the pole and how it moves, and so focus on that column to identify the trend. Number two, what is the total distance the pole has traveled over the time shown? So you're going to focus on the middle column there. That represents the distance moved. And so from 1948 to 2001, what was the total distance? And then in question number three, it says, using this data, predict the average speed of the pole's movement between 2001 and 2010. Explain how you determined your answer. And so you might, in order to make this prediction, you might make a graph of this data and kind of look at what trend the graph shows in order to predict for 2010. Or you can just look at the data in the data table on average speed and kind of use the trend to make your prediction. But let's take a look at the prompt and let's see if I can give you some more information. When Christopher Columbus sighted land in 1492, he didn't know what he had found. Instead of a map, he had used a compass for navigation. A compass is a device that has a magnetized needle that spins freely. A compass needle usually points north. During the time of Columbus, no one knew why the compass always pointed the same direction. An English physician hypothesized that the Earth was a giant magnet, and that is why the compass behaved as it did. The physician was correct. Just like a bar magnet, Earth has a magnetic field surrounding it and two magnetic poles. Earth's magnetic poles do not match its geographic poles. The angle between the geographic north and the north to which a compass needle points is called magnetic declination. This is a natural occurrence in magnets. Earth's magnetic poles move slowly over time. The data in the table show the position of Earth's magnetic North Pole in specific years. Okay, so this really goes back to the magnetic North Pole and how during the time of Columbus they didn't really have the information as to why a compass needle always pointed north, but it has to do with the Earth's magnetic poles. And so the questions really don't pertain to the reading as much as they do the data table. And so if you focus on the data table, you should be able to answer all three questions. Just kind of a reminder on number three, to make a prediction, you probably need to create a graph. But let's read it again. Let's see. Using this data, predict the average speed of the pole's movement between 2001 and 2010. Explain how you determine your answer. And so you might be able to use the trend in the data table, but creating a graph might be an easier way to predict the average speed. So anyway, I hope that helps you, and we miss you and are looking forward to hearing from you soon.